Hello, Randall. Hello, Gabriel.
Hello, Randall.
Hey everyone, how's it going?
Oh, pretty good.
Pretty good here myself.
Good.
Let's give it maybe a couple of minutes to let people
Yeah.
join and
Trickle in.
yeah.
Hello, everyone. This is David Wheeler. Can you hear me?
Yes, we can hear you. All right, I'll put the link to the meeting document into the chat. So please go ahead and mark your name in the participant list. And if you have any open items for the agenda, please go ahead and add them as well.
Hello, everyone. This is David Wheeler. Can you hear me?
Hello, David. We can hear you.
Excellent. I have unfortunately must drive while doing this, so I'm doing the best I can.
Thank you for making the effort to join us regardless. All right.
David,
So,
how are you going to look at compiler flags while driving?
In my mind's eye.
I have faith in you.
I mean, I take most of my morning meetings in my car.
I try to avoid doing this, but I have a doctor's appointment, a checkup, an eye checkup that I can't move. So you do what you can when you must.
Fair.
I can see that. There it is. There it is.
Insert rim shot there. At least one of the topics I know that we're going to be talking about today is much as a broader topic. I don't need to see something to have the discussion. And it involves a number of flags that I intend to propose. I'm hoping to convince folks of my viewpoint, or I hope that other people convince me that my viewpoint is wrong, and I will learn something. Either of those outcomes is awesome. But I think we need to hear both sides of the story and some sort of rough consensus.
yeah. All right. I think we can get started. So we're quite few today, so I will try to make some notes at the same time. And I think we have like the first item on the agenda is the Microsoft SDL C++ hardening guide. And
Yeah.
Gabriel?
That's actually a colleague of mine who's supposed to be here, but I can start it. He's supposed to be here. I don't know why.
Okay. Well, should we give him a couple of more moments? Yeah.
Yeah. Let me see if I can reach him. I mean,
Please.
he's on the west coast just like me, so I think he's not used to.
Sure thing. Yeah, sure thing.
Yep. We understand. I will say just, I mean, the details always matter, but I'm certainly excited about the idea.
Yeah. In the meantime, do we have any new friends who would like to introduce themselves? Everyone seems familiar.
Okay. So I can't see the agenda, but I presume very soon we're going to continue on the topic that we ended last time on.
Yeah, exactly. I think that now, while I think that Gabriel is now calling his colleague, so maybe in the meantime we can have like a quick. Maybe in the meantime we can have a quick look at the other open issue from last time. So we had this GCC-V section where there were some comments about adding adding a recommendation for doing sort of explicit flags and then this note about ordering, and I tried to address this in a pull request for this Randall's fork. I don't know if anyone has had a look at the wording I proposed. Do we have any comments on that while we wait?
I have not taken a look at it, Thomas, but I will take a look at it today and I will comment back.
All right.
Yeah, I haven't taken a look at it, and I shouldn't while driving.
Yes, fair enough. Yeah, but we can continue that offline. But suffice to say, there's some material to look at now to get that forward.
Is there a way to briefly summarize it? And I mean, I guess your basic bottom line is that ordering matters. Okay. So presumably the order that we give them as the recommended set is a workable order.
I would think so. So I think that maybe like the risk comes more from that if you try to combine options like this, if you have like stack protector strong, stack protector all, then might get it. Yeah, but I think that we don't have like in the recommended order, we don't have sort of duplication like that. And right. Either way, I think in this section, like the maybe sort of takeaway is that if you can look at this output of this GCC-V to try to understand in which order they occur from like the default set, right? So you can try to avoid issues. But then maybe if there are sort of specific issues on specific flags, maybe that should go into their specific sections. So I just did like this very high level statement about this order. Yeah, so this is like part of this Randall's branch now, so we can have a look at that offline and see if we can get more.
Yeah, just an update. Once we're done with this, I think I'll just proceed to present the document.
Okay.
He's not responding to a call, so.
Okay, but maybe we can go forward with that agenda item now then. So so you have some material on the Microsoft SDL C++ hardening guide.
Yes, let me see if I can share that. So right now it is in a doc file, but of course, once we discuss, we like the idea, we'll turn it into pull request, fully standard format. Share this thing. Can you see my screen? Let's see.
Yes.
Yeah.
I'll try to make it bigger, but so Microsoft usually has the same concept. Oops, probably too big. Boy. Similar concept to binary hardening, and has this notion of SDL that it recommends to its customers, including internal teams. And there is an open source tool called BeanScheme. It's on GitHub that is used to just go through build artifacts, binaries, PDB files, and so forth, trying to make sure that all the policies and restrictions are followed. And it has been used for a very long time in the company, long before I joined. It's all open source. The rules are also documented on GitHub, and the tool can tell you very specifically which the tool can tell which rules are not being followed. So you have categories of error categories, and then you have warning categories. So errors are things that absolutely need to be fixed before shipping any product. And warnings are things that the tool is not quite sure get it right. So it requires a bit more attention and care needs to be exercised before fixing them, and so that's kind of lower confidence, validation there. So in terms of compiler flags and safety, I know, for example, last week we talked about having a bound checking in C++, where you define minus the glib stood C++ assertions. The recommendation from Microsoft is, of course, doing that, but actually use what we call the C++ core guideline support library that provides those bound checking for contiguous containers, vectors, and so forth. So you don't have to define anything on the command line. You have to use those types, and you have static checkers that tell you exactly when to use those. Sorry. Was there a question?
Yeah, I mean, the comments about using the C++ classes that do automatic bounds checking make sense to me, but that requires you to use C++. If you're using straight C, that's obviously not going to work. So I'm guessing that at some point, Microsoft says use, if I recall correctly, it's /GS. But I've used the Microsoft compiler.
Yes. So there is more to this than the 2 pages document that this is more of a high level summary than a detailed set of rules. If you're using C, then there are a bunch of other stuff that you need to follow. If you're using C++, then we push in for people to use these libraries that are cross-platform, open source, available, and so forth. Similarly, if you're using C++, we rather people use vector and string as opposed to manipulating char stars or T stars themselves. So you have automated checking. For the parts that you see, if you want to manipulate strings like from strings.h, the recommendation is to use the secure versions. So you have these in Annex K of the C11 standard, 11 and 17 and so forth.
Last I talked with the standards committee, though, I thought that the Microsoft implementation of Annex K didn't actually comply with Annex K. Did I misunderstand that?
Yeah, so there are a couple of functions, not all of them, a couple of functions that have the signatures switched by the time that C11 finished standardization. So there was the implementation, and then by the time standard finishes, then there were a couple of functions have their signatures switched, and that is an issue that we need to address because we can't tell people use standard and then provide something that doesn't conform to those. But those 2 functions, they're well known through the analysis tools, and they will check them for you.
Which ones are they for my edification?
I'm sorry?
Which ones got swapped for my edification?
I'm sorry. I will have to. That is why I needed Mike to be here. I will have to check with the library team. Yeah.
Okay. Yeah. If we want to document, though, hey, use Annex K, we're obviously going to have to say but and.
Actually, it is more than that. So this is the general idea. There is no pull request yet, right? So by the time we get to actually create a pull request, you are absolutely right. We all have to go and very specifically say, this is a danger, you know, this is confusion, and these are the NXK functions. Yeah,
Sure.
absolutely. Right.
Okay.
Yeah. So again, this is just the high level view of what we would like to see, and once we have some consensus there, we'll get into the detailed pull request production and review. Similarly for arithmetic operations, again, this is more C++ than C, and there is a library called SafeInt that recommend people to use. Similarly, in terms of dependencies, the bin scheme actually goes and automatically pull all the dependencies and the flag that we used to compile those binaries and so forth. So in terms of compiler switches, so all the PDBs have to be compiled with ZH-SH256. Debug information, you want the compiler version and you want linker version. And similarly, have ways to include dependencies in the PDB. I think not long ago, Dwarf 5 or 6, can't remember, actually allowed production of source link in Dwarf 2. So, even though this is a different format, I think the capability is also now present in Dwarf. So there is, I would say, for the basic requirement of SDL, there is a switch called /SDL that enable all the security checks that are required. Everybody is supposed to use those for productions, and then additionally get to use bin scheme tool to go and for additional checks. From the binaries production perspective, so on Windows, you've got to use structural exception handling. That's just because that's what the operating system has, and you need to have the switch safe SCH. Similarly, you have buffer check, you have GS, position dependent code execution, and you have same thing, GCC and Clang. Then you have here with MSVC compiler. Similarly, you have codeful integration checks. It's on the same CFI that is implemented in GCC and Clang, but it's quite similar. So you had guard, there are various versions of guard. This is just an example, but it is a huge list of things there. Similarly, it has support for shadow stack on the architectures that support them. And again, for exception handling, protecting the metadata, you also have guard there that allows you to protect against hijacking control flow. Data execution prevention is enabled by compiler switch and XCompat. So those are basically the compiler. If I can get this thing, and on the last bit is not all applications need this, but some application needs to have protection against Spectre, and it has perf implications, and that need to be appropriately vetted by policies. So that gives you a high level view of what the set of things that we'd like to suggest in future pull requests, and I would love to have some debate about these points and suggestions for things that we'd like to see in the pull request.
So there's a question in the chat from Sidesh about this bin scheme. So is bin scheme similar to annobin? And there is a link there.
Okay, I'm trying to get the chat and I'm presenting.
Actually, I was just looking at bin scheme now, and it looks like a little bit more than that.
You got
okay.
Okay.
Sorry, go on, please.
Sorry, go ahead. I should have shared the link to BinScheme in the chat.
No, I was saying that it seems to do more than just track flags, which is
Yeah.
essentially what Anubin does. So it's probably different.
And it has a set of comprehensive rules that it checks.
All right. So I remember
So
that
I have a.
Go ahead.
I'm sorry. Go ahead. Yeah, I'm very sorry. It's hard. I can't see anybody else, so I don't know when I'm interrupting. First of all, just as a quick overall comment, I really do like the idea of a separate document for the Microsoft compiler flags and related things, because CLang and GCC try to be, have a policy of trying to be similar. The Microsoft C compiler is obviously quite different, and so I really like, having it as a completely separate list means that we can, emphasize what best works for that compiler as opposed to the other ones. I mean, the syntax is all different, the options are all different, so that makes sense. The thing that I didn't realize that you also had was this list of recommendations for, like, hey, if you're using C++, use these classes.
Mm-hmm.
I mean, we can have a longer conversation later, but I'm wondering if maybe that might be useful pulled out and separate, because my guess, and it can be wrong, I'd like to hear about it. My guess is that a lot of that's going to be the same across all compilers. And I would rather say something once when we can. If we can't, then let's separate it out. Does that make any sense?
Yeah. Oh, so thanks for the feedback. Yeah, fully agree. When we get to produce the PR, then the things that work for all compilers, for the GSL, for example, it works for all compilers. GNU uses,
right.
And yeah. For the flags, I do agree that the flag spelling is different from Clang and GCC. However, I just think that the general idea is that they're trying to get to kind of basically same for everybody. So, the thing that I would like to see is if we can have a structured document where these basic ideas that are the same across all compilers can just be found in one place, as opposed to just, oh well, if you're using this weird compiler, just go over there, and then having a section for saying, well, Clang GCC share these notations, and here is what would you say. Otherwise, I think the document will feel like you have one set of compiler, the other one is kind of second class, which is kind of weird, if you see what I mean.
Got it. Okay. Yeah. We actually have cited a number of other documents that try to do the same sort of thing, and one that does cover the Microsoft C++ compiler compilers does exactly that. It has one section for CLang and GCC, and a separate section for the Microsoft ones, and that would work too. That'd be great. I think trying to create, say, one table to rule them all and trying to put both spellings is just, it's going to be a lot of work for no gain. So sure.
I agree. Just one gigantic table that has everything will be, probably not very useful. But I think separate section in the same document might actually be useful, because I think every time we introduce indirections, we're pushing the information down the stack, and we're all programmers. We know how it works.
Yes, but okay, yeah, I'm good with that. I was much more worried, to be honest, about the trying to create one massive table where, like, there's a column for GCC and CLang, and in the same table a column for the Microsoft ones, and that would require like exact one-to-one matching. I don't think it's actually true, and I don't think we need to try to make it true. We just want to find, hey, for this compiler situation, what are the best options for you?
Yeah. Great. Thanks. That's really.
So yeah, that's great.
Yeah, I'm also wondering that are there sort of features where you can find this sort of like a one-to-one mapping, right? So you have like, for instance, this like this CET compatibility, which presumably is very similar to GCC, like what GCC and CLang does, because it's based on the underlying hardware feature, right? But then, for instance, like the
Sure.
control flow guard can have some differences to like CLang's implementation of CFI, right? And then it might also be sort of a little bit misleading to try and suggest that there is sort of like equality between these if there is like actual differences, right? So I guess that for
Right.
each of these there needs to be sort of like a judgment call to be made, that is it like a sort of like a common feature that we already have a section for, and then you cover just like what the sort of equivalent option is in the Microsoft compiler, or whether it actually would make sense to sort of somehow keep the Microsoft compiler sort of completely separate in terms of the document organization, but then
Right.
whether
And I'm right. And I'm arguing for the latter, because trying to work out all those equivalences and semi-equivalences, I'm thinking that the normal reader isn't a compiler creator. The normal reader is someone who's writing software. They don't care what the option equivalences are. They just want to copy paste the recommended options and paste it into their build environment. Thank you very much. They can't quite just copy paste, because there's probably some issues. So now they need to read the docs to figure out which ones to apply. But again, they don't need the equivalent information.
Agreed. I mean, so in what you're saying, Thomas and David, like we have control flow. We know in our CFI, we know that's the topic, right? We have just section topic. And okay, for this compiler, this is how it works. Copy and paste that, move on. And for the other compiler, that's how it works. Move on. Like when you separate the document, and we do have a lot of software open source is done on Linux and Mac, but a lot also is done on Windows, and then people do cross-platform builds, right? So they need to be able to quickly find, control flow integrity, that's what I need. Data protection, that's what I need, and as opposed to constantly juggling between different documents. So I don't think it will be our job, or we will be able to do a very good job at trying to describe the equivalence or where they differ. I mean, that's a job that I can't do. And I don't think any of us should be required of doing.
Okay.
Yeah, and then,
at least what I'm envisioning. I'm sorry,
go ahead, David.
Okay, yeah, I can't see what other folks are doing. So at least what I'm envisioning is two sections of the same document. Then this one section GCC CLang, the other section Microsoft, and but the good news is if they're in one document, it's super easy to link from one to the other and be able to say, hey, there's an equivalent over here, if we want to add that information as we go. But if they're two separate sections, we're not forced to claim equivalences when they're a little dodgy. And for a typical user who's going to want to say, I'm using compiler X, please give me the list of stuff to do, they can just immediately jump there and get the stuff to do. Is that, am I understanding correctly?
Oh, is that a question for me?
Just really for the group, but but
Yeah,
you're
makes
part of the
sense.
group now, so yes. I'm actually excited about this.
Oh, sorry, go ahead.
I was going to say I'm excited about this. I think this will be an important part.
Yeah, do you want to respond to that, Gabriel? Please go ahead.
Yeah, so I was going to do that, but Randall has hands up, so I don't want to.
I was just going to mention that at one point we also discussed about the Intel and AMD compiler And we said that all of those would be separate sections in the guide if we got around to it, because I think we were trying to contact some people and whatnot. So
Yeah.
I don't know that the Intel one is going to be separate, because the Intel one pretty much tries to follow what the GCC and CLang ones are. I mean, down to exactly what they do, the option syntax and the functionality and so on. In many cases, the Intel compilers don't support them, but if they do, they tend to be the same.
Mhm.
So I think that's TBD once Intel comes back with the information. They're still kind of gathering the information.
Yeah,
So
we have
it could be a different section. It could be combined.
we have Krob wanting to jump in there.
Yeah,
Hopefully-
Oh,
I
please.
apologize. Diana was supposed to be helping us. She's on our side on Intel, and I will. This time is really inconvenient for her, so I'm going to try to get with her out of band and see if we can do some asynchronous review and suggesting so we can get better participation from Intel side. So I apologize, team. We'll do better.
I mean,
No,
6 a.m.
all right.
6 a.m. is a pretty big ask. I totally understand that.
Yeah, that's all right. But so it seems so. I also just wanted to comment basically what David was saying earlier, that what sort of we have as a tool is to play with this sort of like interlinking the document, right? So it sort of somehow would seem to me that there is like a little bit of like a consensus around this, that a separate section within the same document seems to be like the best alternative, and then we can try to create this interlinking so that when there is sort of potential options that have sort of strong equivalences, it can then refer to that this same feature is in the Microsoft compiler, or this same feature is in the CLang and GCC compilers under a different name, and then presumably also a separate table in the beginning with the actual recommended options. And I think that we have sort of already started this discussion around also like separating. So right now we only have like sort of like this warning table, and then we have the recommended options table. But I think that there is also sort of indications that we should sort of separate the recommended options into like something which maybe become then recommended options for GCC CLang, and then other tables with sort of other options of interest, but which aren't necessarily strongly recommended. So I think in that sense, I don't think there is any problem with having like a separate table with recommended options for the Microsoft compiler as well. And I guess that we will just try to ensure that we have like a too long didn't read section in the beginning that gives like a fairly good overview as this document grows ever stronger. But I think it's also like a really good strength to sort of actually try and combine a lot of this information into the same document, because I think that we are already at a point where we have quite a lot of information that hasn't been collected before into one place, and this brings it further.
Actually, I actually like the work you did earlier. I composed a message that I haven't sent yet, but I'll do that right after this call, to send to the C++ standards community and say, hey, when your language, to use it practically, requires these sort of things just to make it moderately safe, what does that tell you? What do you want to do about it? So I actually, having this information collected in one place is really useful. Thanks.
Glad to hear feedback like that. Okay, but I guess that then sort of the next step is for you and your colleagues to then
for me and Michael,
in what way you want to contribute this and turn this into concrete PRs.
Mm-hmm.
And I think that we should maybe sort of continue on to this topic of like how to divide these tables, right? Because that's sort of where we left this discussion at the last meeting, where we were specifically discussing this David's pull request for the fno delete null pointer checks, which was a bit controversial, I suppose. And I think where we sort of left it was that we sort of had this feeling that there should be a separate table for, I think what the current suggestion is, that options that reduce the impact of a vulnerability but also hide problems, either be better to fix the problem, which editors note may need some rewording.
Yeah, I have to admit, I'm actually very confused by the claim because I don't even think it's true. The hide the vulnerability implies that if you don't use this option, the vulnerability will be discovered. And we didn't have time to discuss this, so maybe this is a good time to switch to that topic. Or are we moving on to this topic?
Yeah, sorry. I think.
Yeah, because there was that claim was made, and then the call had to end. But I was very perplexed because I didn't have any evidence that that was actually the case. What the option says is that when I write code, it will generate the code into the object code, even if otherwise I think I could optimize it out. But it doesn't hide any vulnerabilities. It simply enforces the running of code that's written in the source code. That's not hiding at all. If it got to that line to run it, it's already been skipped. And if you've got a tool that can detect it, it will detect it regardless of the option. So we might want to add a section of optional things like that, but this seems like a terrible candidate for it because the argument isn't true. If someone can show me where that's true, I'd love to know that.
Go ahead, Gabriel.
Oh,
Sorry.
yeah. So the claim is a little more nuanced than that, David, I think. The null check for that particular line, the compiler will keep it. Usually what happens is that,
No, wait. No, I think you're misunderstanding what this option does. All the option does is say, if you think you could optimize it away, generate the code anyway. The vulnerability is there, whether or not. The vulnerability is actually still there.
I haven't finished. I haven't finished yet. So what I'm trying to say is.
Oh, okay. Sorry. Go ahead. I thought you were finished. Go ahead.
No, I didn't finish yet. So the option will require the compiler to generate the null check, not remove it, even if they can remove it. But usually that null check, that null dereference, where the actual vulnerability is, usually happens before that, right? Usually happens before the null check. All the null check is doing is, well, I'm going to give you belt and suspender, but that's it. But the fact that a null pointer was dereferenced before the check has already been seen by the optimizer in some form. All that option is doing is to keep that if in a condition check that is written explicitly in the code, but it doesn't prevent the optimizer from actually using that null dereference knowledge previously to do some other optimization transformation that we wouldn't have wanted to be done, which is what I think.
That's correct.
Yeah, I think that's what the claim was about. Like you're not actually preventing.
Oh no. Yeah, if you heard me claim.
Oh, did we lose him?
I think we lost him. Yeah.
Ouch.
Let's see if he will rejoin. I think in the meantime we can maybe sort of try to approach this a little from another angle, because I think that there wasn't necessarily much objection to like adding these options into the guide itself. Okay, now
he's back.
Now he's back. Okay.
Yeah, sorry about that. Yeah. No. basically, I'm sorry, I suddenly got pulled off. Yeah, so yes, the dereference can occur even with this option flag on. The point of the flag is not to eliminate all vulnerabilities. The point is to reduce the impact of vulnerabilities. But I do think that reducing, I mean, if you look at the definition of risk, it's reduce the likelihood and reduce the impact. And this is a very strong de-risking option because it tends to reduce the impact of vulnerabilities if they aren't detected by other means. And sadly, they aren't always getting detected by other means. Clearly, it's better to eliminate the vulnerability, but we haven't been perfect at that yet.
Yeah, but I also sort of a little bit feel that this sort of discussion around this, I think that there wasn't like really much objection whether this option should be added to the guide or not, but it's like a more of a question that we may need a different category for these options. Because I think
Why?
that we all, because I think that like in the end you will have options which sort of in the end are going to be a question of judgments and different opinions, right? So we already have now comments on the in one of these PRs on like this whether we should recommend this V error, so like turning all warnings into errors, right? And I think that there are these options that can be fairly said that it's sort of up to your preference.
Yeah.
Right. So, and I think this kind of also falls into that category, right? So I think that there are sort of strong.
Okay. Let's separate the two out. I totally agree with W error. In fact, W error is very, very good if you are one of the main developers with using a particular stable compiler. It's terrible to include when you're distributing source because you don't really control the compiler being used by the recipient. So I would agree that's very much a judgment call. But the reason for the judgment call is because it depends on your use case.
Right.
I'm a little confused on this one because under what use case do you want the software to do the wrong thing and increase the likelihood of vulnerabilities? I can't see a use case for that.
I'm not actually sure it is about wanting the software to do the wrong thing. So I agree. We all want to harden or to reduce risk and to reduce impact, right? So the real question is, when we recommend any of these options, we're kind of training developers, pushing them on a certain path where they feel like if they turn them on, certain classes of errors or eliminated, or if they're not eliminated, the impact is reduced. This particular option seems a little bit more of judgment call from my perspective, because all it does is to say, it meets the check in this particular case. It doesn't push the developer in a direction of actually addressing the core problem, right?
It has no effect on whether or not the developer does. So I guess the question here is, are these option flags intended for developers only, or are these also intended for operations? I'm assuming that these option flags are also intended for operations, and it would be very unwise for developers to not develop software, in a way that is non-aware and in generally not using the flags used in operations. And I probably should give a little context here. The Linux kernel folks have found that it is basically not possible to never make a mistake when writing C code. And so they very much require and include a number of options like this, where we are doing our darndest to eliminate mistakes. that's too hard. So we make sure that in operations of the Linux kernel, we're going to reduce the impact of any mistakes we might make. And this is an example of actually several of these kinds of flags. And if you and they do it in development too, because they want to make sure that what's tested in development is what's going to be shipped to production.
Yeah, and even if you actually remember last time we discussed this, I was like, yeah, for OS, like you really want to have this thing going on, right? So I think I agree with you on that. One context that you're adding here is like, is it for operations or is it just for developers? And I think that it's in a additional information, which for me, so I wouldn't call it a judgment call. It wouldn't move me from, I wouldn't call it judgment call. Like it's context dependent. That's how I'll put it. Right.
Okay, but I would argue that if the only context you care about software in is not operations, I mean, I'm grinning because of course we all know that the only reason you write software is because eventually you're going to use it, right? You obviously.
I know. So I agree, but in the context of kernel, not removing null check is like there is absolutely no debate in my mind, because in fact the rules that the kernel follows are not really the C rules. So you can't apply the language C rules to kernel and not expect disaster to happen. On the application side, even if the application happens to be deployed in operation, things are different, right? That's where the context in. So I don't think I'm arguing against the option as Thomas pointed out earlier. It is more the category as opposed to like, oh, we shouldn't have it. It's more about the where category.
Got it.
I think we also had Randall raising his hand at some point. Do you want to jump in?
I was just asking for a better clarification of operation, because I understand what you said, David, but I still feel to a certain degree that would still be kind of a developer thing. But I do agree there is an operational standpoint there, like Crow saying operational considerations. I do agree. Like there is an operation, like what you're saying is correct, but I'm still a little confused as to where the line between operational and developer gets drawn.
Okay, when I say developer versus operation, well, when I say developer, I mean basically I'm sitting down, I'm trying to modify the code, I'm debugging the code. There, I'm in my development camp. Okay, as soon as I say, oh, I'm going to take this software and run it on real data and try to actually use the software, we're now in operations. It has nothing to do with kernel mode or not. It has to do with whether or not there's a customer. Okay. And now I actually do agree with you that there's a whole lot of differences between C used for kernel development and C used for applications. I don't think this is one of them, by the way, because null pointer problems are notorious. Actually, across every language that supports nulls, null dereferences are notorious. The primary purpose of the Java compiler is to produce null dereference errors. Occasionally produce code that works. I say this jokingly, but my point though is that null dereferences happen not just in C. It's a really common mistake to make across many languages for reasons I think we all understand. And so basically the reason to turn on these kinds of options is to reduce the impact of problems in operations. Now, why do I emphasize operations? Because every time the developer does something different from operations, now we've got something that a bug or problem that the developer won't see, but operations will. So you debug symbols and so on, got it. You need some extra symbols during development sometimes. But in general, you want to keep your development environment, and particularly your test environment, as close as possible to operations so that it actually will work in operations. So while sure, inserting the extra code during development is irrelevant because if it's only in development, because you're not using real data, but you will use real data in operations. And if you're not using the same code, generating more or less the same code in development, you are setting up operations for trouble.
We also have a comment from Krob. Should we consider a section for operational considerations? Can I ask for a clarification there? That is it kind of like a single section for operational considerations in general, or a section like this for each option we are discussing?
I would defer to the group, but potentially there are a subset of these flags that maybe an implementer may deploy versus a developer. So maybe we could collect that into a section towards the bottom, perhaps.
It's possible, but again, I think that will be unwise in this case, because if it's not in development, then it won't be tested. And if you're not testing it, you're creating mystery problems in production.
Sure.
I do agree with you that adding an operational section might be useful. I don't think this is one of those examples. I can't think of any cases where in development it's okay to dereference null pointers. That's just not a thing.
So I'll let you speak in a moment, Gabriel. I just wanted to jump in with a little bit of another point of view here, and that is that so some of these discussions I'm having with the developers I'm working with is that what they are sort of hoping from like this type of guidance is also some kind of idea of which options to prioritize, right? So if you dump like a huge list of options on them, they're going to kind of get a little bit scared, and they need to sort of pull off resources to actually test each of these options in separation, right? And like often, like how do you actually get these deployed in production is that you will convince them to deploy them in testing first, right?
Right.
And
in fact, I think it'd be shame not to.
Yeah.
Please test what you're going to ship.
Yeah, and I think that sort of like with that in mind, I would personally be in favor of having like a separate table for this, just that we could have sort of like a little bit of this sort of separation between options we feel are really important, and then options that you should consider, but after you have considered the really important ones, right? Also to avoid having like a massive table of 40, 50 options, and this is also a consideration of in which order we address these, right? So which are the important ones should ideally be somewhere in the beginning of the document. But that's sort of maybe how I would also sort of motivate this sort of as a little bit of like a separation between what sort of we cover where. And now Gabriel wanted to comment on this, and then we have Randall after him.
And yeah, you say a great deal of what I was going to say, which is we need to prioritize. David, you made actually a very interesting point about testing, and like, well, I'm not arguing, and I'm not hearing anybody here arguing that, oh, I absolutely want to dereference null pointer. That's not what the argument is about, as Thomas said.
Right, and I know, but I'm confused about what the argument is, but carry on.
Yeah, and the other thing is, I think we also want to recommend people do fuzzing because of how this particular optimization interact with a bunch of other stuff in the generated code. Like when you're doing testing and doing fuzzing, this is the sort of vulnerability you want to increase the chances of discovering it during testing and fuzzing. And if you enable this option, you decrease the chances of like the wrong thing happening during fuzzing that will expose the problem, right? And which is why I would actually not prioritize it at all during fuzzing and testing. Like do not include this option when you're doing testing and fuzzing, so that you can expose increase the chances of exposing the bad behavior. And that goes back to what Thomas was suggesting. Sorry, Randall?
I had a question for David and also for you, Gabriel. So
Mhm.
what would your opinion at maybe even a question for Sadesh and also Thomas, I guess the whole group. So would I know that there are ways of enabling flags by default. Would that be an operational consideration? Or is that like so in other words, like if you had options that you wanted to make sure were enabled by default, you didn't want to keep putting the flags. I know that GCC has a way of like just compiling GCC so that it has a quote unquote default profile, which we talked about in GCCV. So are the purpose of those flags up for the operational people so that therefore they have like a GCC that has like the flags that they need to like have working always on, and therefore they don't have to, I'm just it's more of a question more than anything. Because if that's the case, then I would say that those default flags maybe are important. That like if you have a certain set of flags that you always want to have on because you cannot accept software that does not comply with a certain set of rules, then you probably should just compile GCC with your default flags on and never worry about it. Is that my understanding that correctly, or am I missing something?
You know what? I think we're starting. I think I'm starting to see the arguments on this, and I think what we're seeing, based on the previous comments, and it makes it harder to deal with it that way that you described, is if you're doing fuzzing, there is one set of options. If you're doing operations and testing a system against, say, its functional requirements, you want a different set of options. And in fact, maybe we need two tables. One is, here are the additional options when fuzzing to increase the likelihood of detecting a problem. And here's the options you want to use during normal testing and during operations, because you want to minimize the likelihood that a problem surfaces. Is that really the distinction that we're going for here?
I think that would be perfect for that. That will resolve my concerns, but Randall and and others have also voiced.
Okay. All right. If that's the issue, you know what? I think this conversation has been very, very helpful because we have different perspectives, and now I think we're really honing in on what the difference is.
So if I sort of understand this right, what we now call this recommended compiler options table is the recommended options for operations, and then what we sort of want to add is a recommended options for testing that can presumably be a superset of the ones for operations, and perhaps there are some that doesn't actually make sense for testing for one reason or the other, but we have to then vet these specific options.
I would separate fuzz testing from other testing. In general, you never want to test software that has a byte difference from the thing you're going to field in operations, because obviously, your test results are not necessarily valid. They exceptionally for fuzz testing, because clearly for fuzz testing, you want to make it more likely to fail than normal. So I guess what I think for simplicity, it'd be easier to list, here's what you're going to use for operations and testing of your operational software. And here's the separate table, because I think everything in GCC and CLang can be undone by adding them later. So I think you could add a table of, and then add these flags that undo some of that stuff to make the system more likely to fail if there's a problem. And that gets you to your other concern about, how do I make sure that it's more likely to fail?
Okay, but I think that we are sort of nearing like an actual concrete suggestion on how to rework the document. So maybe I can take as an action point to try and get this started, but I think that this will need more eyes on than one person, but I can try to start making the changes, and we can maybe continue this discussion offline. And then I also hope that next week we can also discuss other matters, because we have a lot of things on the agenda we didn't have time for this time, but I think it's time to call it a day. Or but thanks everyone for a really great discussion this time. I did some notes on your presentation, Gabriel, but maybe you can have a quick look whether I make sure that I got everything right, and I'll also try to summarize this discussion now after the meeting. But thanks everyone for attending, and
Thank you. This has been exceedingly useful.
Great.
Yes,
Glad to hear.
thank you so much. I think a lot of progress was made today.
Yeah, this was a really great session, and I hope you all have a very good day, and hope to see you all in 2 weeks.
Okay, thanks.
Bye bye.
Excellent.